Okay, pre-calculus students, last unit we'll be diving into for the rest of the school year, Unit 6, and it's about identities and equations. Identities are an expression that is the same as another expression, or you could make it the same as an equation is an identity. If you say x equals to 2, that's an identity for that particular problem. If you say x plus 2 equals to x plus 4 minus 2, that's an identity. It's the same thing on the left and the right. So today, day 1, we're going to do some basic, very basic, that you can't leave pre-cal without having an understanding of some basic identities. We've already looked at some that are reciprocal. We've already looked at quotient. You just don't know it. But new ones would be Pythagorean, cofunction, even and odd. I can give you I did give you a copy of this Trig identity chart. Again, this can be added to your cheat sheet. You can use this whenever you need to, especially until you get really good at these identities. All right, so first lesson, we're just going to do basic identities. I'm not going to name all the different kinds. Trust me, these are all basic, the first ones that we all have to learn. A trig identity is an equation involving trig functions that is true for all values. No matter what angle you plug in, they're always going to be true. So whatever you have on the left will be equal to the right, plugging in the same angle. We use them to evaluate functions, to simplify expressions. Later on, we're going to verify identities. We're going to see if an identity is true or not. Okay, so let's talk about some basic identities. These are called quotient identities. And I've made this comment to you many times that the tangent of theta is always equal to sine of theta over cosine of theta. Of course, as long as cosine of theta is never 0, that's a quotient. Sine divided by cosine, that's a quotient. You can flip those two around and say the cotangent of theta would be the cosine of theta divided by sine of theta, as long as sine is not equal to 0. Those are called quotient identities, and you've already been exposed to that. Okay, reciprocal identities, when you flip something, we've done that already too. Sine of theta is the same as 1 over cosecant. And we've talked about cosecant is the same as 1 over sine. Those are called reciprocal identities. Of course, every one of these, as long as the denominator is never 0, of course. Cosine is 1 over secant. Secant was 1 over cosine. Tangent, 1 over cotangent. Cotangent was 1 over tangent. So now we're going to use these basic identities to try to evaluate or find different angles. And he wants us to use, or she wants us to use, quotient and reciprocal identities. There's several ways of solving these things. If we know secant of theta is the square root of 30, all divided by 3 with a negative in front, it looks like, find the cosine of b. Well, obviously, if I use that identity, at cosine, what did I say b? I don't know. Cosine of theta is 1 divided by the secant of theta. So in this particular problem, 1 divided by a negative square root of 30 over 3. Now, how do I evaluate this? Whenever you have a fraction in the bottom of a compound fraction, we take the 1, we multiply it by the reciprocal of the bottom, we flip it, and then it doesn't matter where the negative goes, negative 3 over the square root of 30. That turns into a negative 3 over the square root of 30. We're not allowed to leave a square root in the bottom, which I lied. Sometimes we liked it, but not today. So I rationalize the denominator, square root of 30 over the square root of 30, which is a 1. So all I'm doing is multiplying the first by a 1. But it allows me to say the answer is negative 3 times the square root of 30, all divided by 30. The 3 and the 30 reduce to a negative square root of 30 all over 10. Number 2. If tangent is equal to the square root of 2 over 4, and we also know that sine of the angle x, and this is tangent of angle x, this is the cosine of angle x. We know the cosine of x is equal to 2 square roots of 2 over 3. So we have tangent, we have cosine. Using an identity, find sine. Let's see. Well, I know that tangent of x is equal to, I'm going to use that, the quotient identity, which is sine of x over cosine of x. Since I'm looking for sine of x, I'm going to solve this for sine of x by multiplying both sides by cosine of x. Multiply this side by cosine of x. Cosine of x cancels out. That leads me to say sine of x must be equal to the cosine of x times the tangent of x. Well, if you think about it, I can continue this madness. Let me plug everything I know. Cosine of x is the negative 2 square root of 2 over 3. And the tangent of x is the square root of 2 over 4. Try to put that together, equals to a negative 2 times the square root of 2. Square root of 2 means the square root of 4. Those two actually just cancel out the radical. So that's a negative 2 times a 2. That's a negative 4 over the 3 times 4 is a 12. That reduces to a negative 1/3. So sine of x is the negative 1/3. Last one on the page. If cosecant of x is equal to 7/3, and cotangent, what did I say, x? It's definitely a Greek letter b, beta. We'll call it beta. Cosecant of beta is 7 over 3, and the cotangent of beta is the negative 2 squares of 10 over 3. Find the secant of theta. Okay, let's see, what do I have? Find the secant. I think for this one, I'll resort to looking at the identity for cotangent right now, because secant is related to cosine, and there's no cosine in cosecant. So let me say that cotangent, and I'm winging it, sometimes I'm wrong, is equal to the cosine of beta over the sine of beta. And since I'm trying to pull out cosine, that leaves me with cosine of beta equals to, and multiply both sides by sine. I'm sort of doing that without showing you, but sine cancels out. So cosine of beta is sine of beta times the cotangent of beta. And I know what you're saying. I don't have sine. You're right, I don't. But sine of beta is equal to 1 over cosecant of beta, which is what I have here. So I can come up with an expression for sine by saying sine of beta is 1 divided by the 7/3 right here. Well, when I take 1 divided by 7/3, that's the same thing as 1 times 3/7. That's 3/7. So now I have sine. So I'm going to plug that in down here. I'm going to go equal to, and I'm going to take this sine of theta right here, plug it into here, 3/7 times the cotangent of beta, which was given to me here, negative 2 square roots of 10 all over 3. And let's see, how does that help me? Well, I have a 3/7 and I have a divide by 3. I can see that that cancels. I'm left with a negative 2 square roots of 10 divided by 7, if I'm correct. Okay, let me move on to, I like to put the whole picture here, so in case somebody is still taking down some notes. Okay, let's talk about Pythagorean identities. What I'm going to do right now is I'm going to be honest with you. The only one of these I can memorize is this one. Of course, I don't usually use it with a cosine first. I do it as sine squared of any angle, theta, plus cosine squared of that same angle will always equal to 1. A squared plus B squared is C squared. It's I can show you how that's A squared plus B squared equals C squared on a triangle on a unit circle, but I'm not going to bore you right now. If somebody asks me to prove it, then I'll send off another video clip, but I don't think I want to put you to sleep. My advice to you is memorize this one. The other ones, I can never memorize. Right now, you're lucky. I'm letting you use the formula sheets. But here's what I do when I don't have formula sheets. I just say, what would happen if I divided both sides by a sine squared theta? That means divide that by sine squared theta, divide that by sine squared theta, divide that by sine squared theta. I can do whatever I want as long as I do it to both sides. Sine squared theta divided by sine squared theta becomes a 1, plus cosine squared theta divided by sine squared theta is a cotangent squared theta. And a 1 divided by sine squared is a cosecant squared theta. Okay, well, guess which one that is? 1 plus cotangent squared. There it is. I just derived that. I was just pretending. I said, if I take the only identity that I remembered, sine squared plus cosine squared is equal to 1, and divide it by everything by sine squared, I know I'll produce one of the other identities. Let me play that trick again. If I start out with sine squared theta plus cosine squared theta equals to 1, again, the only one I can memorize, and I'm going to divide everything by a cosine squared theta. Wait for it. Cosine squared theta, cosine squared theta, cosine squared theta. Lo and behold, sine over cosine is a tangent that I've memorized. So that gives me a tangent squared theta plus cosine squared theta over cosine squared theta is a 1. 1 over cosine squared theta, that's a secant squared. Secant squared theta, and abracadabra, there's the other one. So if you know one, you can derive the others. If you ever do not have a formula sheet, you can take a fast minute and come up with all 3 of them. 1 that I memorized and 2 that I can derive on a fly if I have to. All right, those are Pythagorean identities. They're all related to a squared plus b squared equals c squared. So find cosine of theta and tangent of theta. Okay, so it's a twofer. Wants me to find 2 things. If all I know Sine of theta is a negative 1/3. So I know this to be true. What else do I know to be true? That cotangent of theta has to be negative. Well, where's cotangent negative? I'm just going to take a couple of seconds and ask myself, in these four quadrants, cotangent, if you recall, cotangent of theta is considered to be x's over the y's. So if the x is negative, and the y is positive, that would suffice. Well, where are x's negative? Over here and over here, quadrant 2 and quadrant 3. However, y can't be negative. So that takes away the quadrant 3. So I can be in that quadrant. Or I could have x be positive and y be negative. Would also give me a negative cotangent. Well, where is x positives and y negatives? Well, positive x's are in these two quadrants, but the negative y would be in this quadrant. So quadrant 2 and quadrant 4 could be my possible, where my angle, what angle I'm talking about. However, remember what this has to be true? Sine has to be negative. So that eliminates quadrant 2. So I'm only going to be sitting here in quadrant 4. Just keep that in mind. Quadrant 4 is going to be special. So let's go back to work here. If I want to find cosine and I have sine, let me use my Pythagorean identity that I know and I memorized. Sine squared theta plus cosine squared theta has to be equal to 1 all the time. No matter what angle you choose, as long as both of those are the same angle, it'll always work out. You can use your calculator and prove it to yourself. Okay? Doesn't matter. Degrees, radians, doesn't matter. So I know sine of theta is a negative 1/3. So I'm going to put negative 1/3, and I'm going to square it, plus the cosine squared theta, which I don't know, which I want cosine because he's asking me for it, equals to 1. Negative 1/3 squared is equal to 1/9, positive, plus cosine squared theta equals to 1. Solve this for cosine squared theta. Cosine squared theta must be equal to 1 minus 1/9. Well, 1 minus 1/9 is the same as 9/9 divided by 1 minus 1/9. That's going to be the same thing as 8/9. 8/9. So I'm looking at cosine squared theta is 8/9. Square root both sides, and I'm going to get cosine of theta is the square root of 8 over the square root of 9, which is the same thing as square root of 8 over 3. Square root of 8 can be simplified into the square root of 4 times the square root of 2, still divided by the 3. That's 2 square roots of 2 divided by 3. So there's my cosine of theta. Cosine of theta is 2 square roots of 2 divided by 3. Hopefully that's one of the answers. Okay. I'm not done yet because I still need to find out what tangent is. So I can use, what identity can I use now? Well, he said Pythagorean, which I had more room. I'm going to run out of room here, but I might have to Move on here. Let's see. Identity, if I'm looking for tangent of theta, let me try this. Tangent squared theta plus 1 was equal to secant squared theta. May as well use tangent squared since I am looking for tangent. So that gives me, if I solve that for tangent, tangent squared theta will equal to secant squared theta minus 1 by subtracting 1 from both sides. So tangent squared theta is what I'm looking for tangent will equal to the secant. I don't have secant, but I do have cosine. If I flip this, that'll be my secant. So I'm going to flip it. Gets kind of ugly, guys. 3 divided by 2 square roots of 2. Then I have to square it, minus the 1. Now, I know it's not rationalized, but it's okay because I'm squaring it. So that turns into tangent squared theta is 3 squared is 9. 2 squared is 4. And so that's 4 times the square root of 2 times square root of 2 is still a 2, minus the 1. That's 9 over 8. 9 eighths minus 1. Well, 9 eighths minus 8 eighths is the same thing as 1/8. So remember what we just found. We found tangent squared theta is 1/8. Square root both sides, and remember that we want quadrant 4. Up here at the top, we had already established that I'm going to take the negative answer, because when you square root both sides, you get plus or minus. Which one do I want? I want the tangent that's going to be negative, because that's where the cotangent was going to be negative as well. And that's what we had a requirement at the beginning. So tangent of theta will equal to the square root of 1 is 1 over the square root of 8, which we said was the same as 1 over 2 square roots of 2. Rationalize that by multiplying top and bottom by the square root of 2 over the square root of 2. That gives me the square root of 2 over 2 times 2 over 4. And hold on, I need the negative. Forgot the negative before somebody yells at me. It's going to be a negative. Tangent of theta is a negative 1 over the square root of 8. Got to remember that because I took the negative answer. Okay, let me unzoom that whole problem in case you're still getting down some notes. Okay, let's see if I can squeeze the next problem in this little part here. All right, find the tangent of x and the sine of x. So again, doing 2 problems in one. If I know for a fact that secant of x is 6/5, also, I know that sine has to be positive. Again, sine is positive in quadrant 1 and quadrant 2. If you remember that, all students take calculus. But I know that secant is positive because it says 6/5. So I know I can't be in quadrant 2. So the answer has to be in quadrant 1. Keep that in mind. That's why they give us this information, to make us get mad. So if I'm looking for tangent, I'm going to use the tangent squared of, we're doing x. Now, do you remember what the identity was for tangent squared? Let me find it up here. It was the plus 1 equals to secant squared. So tangent squared x plus 1 has to be secant squared x, which is kind of good since I already knew secant. You like how that works out? So I know tangent squared x must be equal to secant squared x minus the 1. I already know secant is going to be 6/5, so I'm going to write tangent squared x equals 2. Secant squared is 6/5, so it's 6/5 squared minus 1, which is 36 out of 25, minus 25 out of 25 is the same thing as a 1. That turns into, again, equal to 36 minus 25, 11. 11 out of 25. That would be tangent squared of x. Square root both sides to get rid of the squaring, and I get, let me write it up here, tangent of x. I need the 1 in quadrant 1. Tangent's positive up here, so it's going to be a positive square root of 11 over 5. That's my story that I'm sticking with. Now I need to find the sign. Well, what identity can I use right now? Well, I'm going to zoom in on this here. I might have to erase some of that work over there, but we'll see. If I want to find sine squared x plus cosine squared x has to be 1. Since I'm looking for sine squared x, I will say sine squared x is 1 minus cosine squared x. Do I know cosine? I think I do, because secant is 6/5. If I flip 6/5, I have cosine. So sine squared x equals to 1 minus 5 over 6 squared, which is 1 minus 25 over 36. So I'm going to continue. Sine squared x must be equal to, another name for 1 is 36 out of 36. 36 minus 25 is 11. 36's. Take the square root both sides. I get the square root of 11 over 6. And I want positive because it says sine is positive. So I know it's plus or minus, but the answer I want is in quadrant 1. So sine of x, I'll just reinstate the answer. Sine of x is square root of 11 out of 6. Let me unzoom it here so you can get a clear view. And let me pause it. Okay, last sets of identities, cofunction. It's relatively simple. Remember when we graph sine and cosine? And if I graph sine, look like this from 0 to 2 pi. And yet when I graphed cosine, it did something like that. The truth of the matter is they were the same graph, just sine is, as you could say, shifted. In other words, if you could move the cosine graph, if you move the cosine graph a little bit this way, this red would line up to here. So it would line up by just shifting it. That's what's happening. Sine and cosine are just a shift of each other. That sine of any angle, if all you knew was sine, then you know that the answer to the cosine would be pi over 2, which is 90 degrees, minus the angle you have in degrees. So if it was sine of 30, would be equal to cosine of 60. because 60 and 30 add up to 90 degrees. In other words, these two answers have to add up to 90 degrees or pi over 2. That's the same thing for tangent as well, to go from tangent to cotangent. Tangent of 5 degrees will be equal to cotangent of 85 degrees. They're the same answer. Keep going. Secant, I'm making numbers up. Secant of 20 degrees is the same answer as cosecant of 70 degrees, because these two numbers have to add up to 90. That's the secret of cofunction, okay? So that's what's going on with those pictures. Even and odd has to do with what an even function was. An even function is like a parabola, has symmetry on the y-axis. So when you plug in a -5 here, you get an answer which is identical, -5, +5 here, you get the same answer at a -5 because it's symmetrical across the y-axis. That's what an even function is. And if you think about it, the cosine graph is an even function because you have symmetry on the y-axis. So cosine is an even function. Sine, however, is an odd function. When you plug in an answer here, some x and some -x, this is a positive answer and this is a negative answer. That's an odd function. That's your definition of even and odd functions. Well, the identities that we'll look at was that the sine of a negative angle will be the negative of the sine of a positive angle. In other words, you could basically factor out that negative of a sine, because the sine, let me do my sine curve. The sine of a negative angle, that's this way here, will be the opposite of whatever the sine of the positive angle was. If that was equal to 0.4, that would be a -0.4 down here. Enough of that gobbledygook. I just put you all to sleep. So sine and tangent operate the same way. If you look at tangent, same way. Tangent of a negative angle is a negative of the tangent. Cotangent. Let's see, cotangent would be the same. Cotangent of a negative angle is the opposite of the cotangent of the positive angle. Look at the cosine. Cosine of a negative angle is a positive answer, period. You might say, well, why is that? Well, remember the cosine does this graph here. It's symmetrical. So you go over here and take a negative angle, -x. It's the same answer as the positive x would be. It's the same answer. Because why? Even function. Even function, you plug in a negative answer, a negative value, you still get a positive answer. Okay? And cosine is a lot like secant. Cosecant is a lot like sine. Okay, so they're related. So these get kind of hard. And let's see. Well, they're not hard, but it's hard to understand. Use the cofunction and even and odd identities to find each value. He's telling you that we know for a fact that sine of a negative angle is a -0.97. What does that mean in English? Sine curve is down here then, and there's my sine going up this way. So I'm over here, and the answer is down here is negative. It says that. Then find the cosine of that answer. Well, you might be thinking to yourself that the cofunction of that angle and then 90 minus that angle, but you're doing the cosine of it now. So let me say this. Sine. Still recording? Okay, yeah, sorry. Sine of a negative theta will be equal to the negative sine of theta. That would mean negative 0.97, because that's what this answer is, would have to be the opposite of sine of theta. Divide both sides by negative, you get a positive 0.97 will be sine of theta. Now, why did I need that? Because I want to find this cofunction. Cosine of pi over 2 minus theta should be equal to, what was my function up there? Where's it at? Cosine of pi over 2, where's that at? Right here. Cosine of pi over 2 minus theta is sine of theta. So that must be, there's my identity. Therefore, cosine of pi over 2 minus theta must be 0.97. Just using the definitions that were given to us. Okay, number 7. I can tell you right now, he's trying to trick us, because my angle alpha is alpha minus pi over 2. If I look at cotangent stuff up there, or the cotangent of, there it is, it's pi over 2 is supposed to be first. So he's tricking us. Glad I saw that. Let's see what I'm going to do here. Start with the tangent of negative theta. Since, again, that is an odd function, I know that the tangent of a negative alpha will be equal to the negative of the tangent of a positive alpha. And if the tangent of a negative alpha is a negative 2.36 equals to the negative of the tangent of alpha, and divide both sides by a negative, then I know that the tangent of alpha must be a positive 2.36. Why do I need that? Because we got a cofunction problem here. But I need to address the switch that they've done. So what I'm going to do is, this gets complicated. Cotangent of an alpha minus pi over 2. I need to switch those numbers around because it doesn't agree with my cotangent up here. It doesn't, not that one, this one right here at the top. It doesn't in the right order. So let me switch it around. Should be equal to the cotangent. When you switch two things around, and it looks like a negative pi over 2 plus alpha, that's still not exactly right, because I need pi over 2 minus alpha. See that up there? I need pi over 2 minus the angle. So when this happens, whenever in any class you ever have in math, you can take the cotangent and you can factor out a negative out of the whole thing, leaving, and what I'm going to do is make another parenthesis in there. Factor out the negative, that leaves me a pi over 2 minus my alpha. Okay? Oh, good news. Remember that the cotangent of a negative theta is the same thing as a negative cotangent of theta? I believe that's up there. Let's go look at it. Cotangent of a negative angle. Where's that at? cotangent right here of a negative angle is the same as negative of the cotangent of the angle. By doing that, I can say that this problem here is actually equal to the negative of the cotangent of pi over 2 minus alpha. Okay, good. That's what I wanted to see. Which is equal to, all I did is rename it. All I've done is change it. It's the same as this problem. It's just been, a lot of algebra was done. We know that the negative cotangent of pi over 2 minus alpha must be equal to what up there? What has it to do with tangent? Where is it? Cotangent of pi over 2 minus alpha is tangent. Right here, see? But don't forget, that would be negative tangent of alpha. And wait a minute, tangent of alpha, we did that. Tangent of alpha was a positive 2.36. So I take that answer. Tangent of alpha was a positive, so it's a negative 2.36. Forgot what it was. Whew, that's a lot of work. I know your eyes are spinning. One more, last one. Did they do it to me again? They did it to me again. They switched those around. Thanks for nothing. I need to fix that. And all I'm doing is going to change things around. I'm going to say secant of beta minus pi over 2 is still equal to secant of a negative pi over 2 plus beta. Factor out the negative equals to secant of a negative out front of, I'm factoring a negative out. So that's what I'm doing. I'm factoring a negative out of this negative. I'm factoring a negative out of this positive. So that turns into negative of a positive pi over 2 minus beta. Now, what do I know about the secant of a negative angle? It's just like the cosine. I believe it's going to be equal to the positive of the secant of pi over 2 minus beta. Let's go up there and look. Secant of a negative angle. Where is it? Secant of a negative angle is the same thing as positive secant of the angle. Whew. So I think I have it right. Secant of a negative of an angle is equal to secant of the positive of that. All I've done is rename the problem, which we're saying is equal. It's still equal to negative 3.62. .62. Okay, all I've done is rename this problem to make it look the way that the identities were at the top. Find cosecant of a negative theta. Is that what that is? Cosecant, okay. So what would be the identity that relates secant and cosecant? Let's go up and look. Cosecant of a negative angle. Cosecant of a negative angle has to be a negative of the cosecant of the angle because it's related to sine. So let me write that out. Going from this thing right here. Cosecant of a negative beta is equal to a positive, no, a negative, it's related to sine, so it's negative cosecant of beta. how are these two related? How is cosine related to this one? Is that up there? Let's find it. Secant of pi over 2 minus the angle. Secant of pi over 2 minus the angle. Secant of pi over 2, there it is. Secant of pi over 2 minus theta is cosecant of theta. So we know secant of pi over 2 is cosecant of beta. Look at that again. Secant of pi over 2 minus beta. Secant of pi over 2 minus theta, right here, is cosecant. So this is cosecant of beta, must be equal to negative 3.62. And what was I looking for? Cosecant of the negative angle. Oh, so that whole line here, cosecant is the negative, I can't even read my writing here. Cosecant. Cosecant of the negative angle is a negative cosecant of beta. And that's the one I want. So negative cosecant of beta would be a positive. That would have to be changed. Negative cosecant of beta would have to be negative 3.62. Therefore, cosecant of beta would be a positive 3.62. Please unzoom it all. And guys, nobody enjoys those cofunctions and even and odd functions. Nobody enjoys it. I'm going to unzoom everything so you can see everything I've done without being zoomed in too far. You can always pause. And have fun with it. Because here's your homework. All. It's not that many problems. 1, 2, 3, 4, 5, 6. Bye. 7, 8, 9, 10, 12. 12 items. Have fun with it. That's it.